So we're given the question, the graph of the function y equals 3x to the fifth minus 10x to the fourth has an inflection point where we need to understand first and foremost that this question is asking for us to find inflection points. So that's an important word. So that means that we're going to have to use the second derivative to determine critical points, and from there where the function translates from negative to positive or positive to negative in relation to those critical points on a number line. So the first step would be, of course, to rewrite the function y equals 3x to the fifth minus 10x to the fourth, and then go ahead and find the first derivative, which would be y prime equals 3 times 5 x to the fourth minus 10 times 4x to the third, and that comes out to be y prime equals 15x to the fourth minus 40x cubed. Now from there we can take the second derivative, so y double prime equals 15 times 4 x cubed minus 40 times 3x squared. Y double prime equals 60x cubed minus 120x squared. So we need to find our critical points for this function. We can factor out a 60x squared, and we're left with x minus 2. So we know the critical points that we'll be dealing with, 0 and 2. To determine where we have inflection points, we can go ahead and draw a number line. We have 0, and then we have 2. And remember, the question asks us if you graph the function, the graph of the function y equals 3x to the fifth minus 10x to the fourth has an inflection point where, so we need to determine where the inflection point on the graph will be. Anything less than 0, of course, so any type of negative number is going to be a very big negative number. So big negative minus a slightly less big positive is going to work out to be a negative every time. So we've indicated that less than 0 on the number line, you're going to have a negative. An easy test value between 0 and 2 would be 1, for instance. So this would be, if you plug 1 back into the original function, 3 minus 10, so that would be a negative number. I guess we should go ahead and write our negatives down here. Forget about those. So we have a negative number there. Then we need to have a test value for anything greater than 2, so that would be a large infinity. A large positive infinity would result in a big positive infinity minus a slightly less large positive infinity. Regardless, that is in fact a positive infinity. As you can see here, we have a sign change at the critical point of 2, which means, of course, that the inflection point x value will be 2, and plugging it into the original equation, y equals 3x to the fifth minus 10x to the fourth, y equals 2 to the fifth minus 10 to the fourth. That comes out to be negative 64. So your inflection point will occur at 2, negative 64.